Hello, so this is number 10, and first we'll find the vertex form. Now it's a little complicated by the fact that the leading coefficient is not 1, and I'm going to mark that off to the right here, that a equals 3, and that's greater than 0. I'm writing that off to the right as a reminder that the parabola will face upward because the leading coefficient is positive. But what we need to do here is to a couple things. This 9 is just going to hang around. It's the 3 and the 12 that need to interact, and I just don't know of any way to avoid this kind of complication along the lines of something like this. Minus 4x. I'll use a closed parenthesis right there. Okay, so what we've done is to factor out 3 out of the first two terms. There's no way around that, at least not that I've seen. Now, the idea is within the parentheses, the leading coefficient now of x squared is 1, and then we're off to the races for completing the square. And we proceed just like we have before. We focus on the b term here, which is negative 4, and take half of that and square it, the usual routine. So here we go. We'll have negative 4, take a half of that, which gives us negative 2, and then we square negative 2, and that's positive 4. So positive 4 comes in out of thin air. It's the magic number. Well, it's sort of the magic number, actually. Keep in mind that what we have brought in out of thin air is not just 4, it's 3 times 4, 12. 12 has come out of nowhere. Therefore, we need to subtract out 12 off to the right here. So the balance is good, and we can now say that the vertex form would be 3 times x minus 2 quantity squared, and I guess minus 3, right? 9 minus 12 is negative 3. Good. So here's our vertex form. And I guess I should put a box around that. And there we go. Okay, very good. All right, so vertex form, good. That's part A. Part B was to identify the vertex. And so from the vertex form, remember the HK routine, so you have something that looks like A times x minus h squared plus k. The vertex will be HK if everything is lined up right in terms of the subtraction going on here and the addition going on here. Okay, great. Therefore, the vertex would be 2 comma negative 3, and put a box around that. So that takes care of part B. Part C is identify the line of symmetry. The line of symmetry is always x equals whatever the x value of the vertex is. So there you go. Done. Now, next in line here is identifying the y-intercept. All right, so what I do is put in 0 for x into the original function, the way it was originally given, where it's expanded all out. That's just the fastest way to do it, and it's always going to come out that there's this last number there, that 9 in this case, which is going to be the y value of the y-intercept, and write it as a point 0, 9, put a box around it. So that's going to be a point on the graph we're about to draw. The next step is the x-intercepts. Students in class were seeming to find that, using the vertex form kind of a look and setting that equal to 0 was preferable to going back to the original formulation of the function, setting equal to 0, and either doing factoring or quadratic formula, etc. And that's fine with me. As you set the function equal to 0, and in this case using the vertex form, we're going to solve for x. We're going to find the x-intercepts. Remember, the x-intercepts are the points on the x-axis where the graph crosses the x-axis. So add 3 to both sides. We're just trying to solve for x here. Divide both sides by 3. There'll come a point, if we're going to be using this vertex form, there's going to be a point where we will be what's called extracting the square root. That is, take the square root of both sides. Remember the plus minus. That's the downside of this approach. You got to remember the plus minus. There are two two solutions here, or at least there can be. Usually there are two separate solutions. Well, the square root of 1 is just 1. So we're talking about plus or minus 1 equals x minus 2. In other words, we're saying x equals 2 plus or minus 1. And let's see, what are we saying? 2 plus 1 is x. X equals 3, and x equals, I think, 2 minus 1, which is 1. Now we're getting to the point we can write a couple more points that represent the x intercepts. We have 1 comma 0 as an x-intercept and 3 comma 0 as x-intercepts, and that was part E. Now at this point we can go to part F, which is to get a basic graph going. We have enough to deal with here. So next page, here we come. All right. Oh boy, he's on the ball. He even got a little graph going there. Okay. Right, so let's see. What do we got? We have x-intercepts of 1 and 3, so right there and there. And I'll label that as 3 comma 0 and a little x with a hyphen, x-int for x-intercept. And, you know, sometimes it gets a little bit crunched, but here we have 1 comma 0, 1 comma 0, and a little x with a hyphen int, x-intercept. And the vertex, let's see, the vertex was 2, negative 3. So that's right down there. 2, negative 3, vertex. So I'm labeling that as well. And finally, we had a y-intercept. What was that? 0, 9. Right. So that's kind of far up there. There you go. 0, 9, y with the little hyphen int, y-intercept. And let's get the graph going. It's not the most elegant thing, but it's not an art class. Don't worry too much. You just want to be sure it's facing upward, that's crossing at the right places, and do include the line of symmetry, which goes straight through the middle of the parabola. So x equals 2 and little ls for line of symmetry. That much abbreviation will be just fine with me. Now, so that's part F. Yeah, we got everything we need for part F. Yeah, part F, yeah. Part G now, part G and everything beyond that, in my opinion, just uses the graph with a little bit of background understanding, but it's not really too algebraic. Part G says identify the domain. Okay, so the domain is all the x values on the parabola, all the x values, and it's really an easy story. For all of these parabolas, every blessed one of them, the domain is all real numbers, which in interval notation is negative infinity to infinity. Let's see, part H is the range. Now the range has more work here. That requires a lot more thought. It always does. Range is all the y values on the graph. Well, as you observe, there are some y values way down here that are not on the graph. It begins really to happen at negative 3. When y is negative 3, then we're talking. It includes negative 3, y equals negative 3, y equals negative 2, 0, blah, 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 on and on and on. And so that's the range. Range is all the range is the set of all y values included on the graph. Okay. Let's see. That's part H. Part I was identifying intervals where the function's increasing and decreasing. Okay. So, parabolas are pretty stable things. You either have a story of decreasing, increasing, or increasing, decreasing. That's really it. Here we have a decreasing, increasing story because from the left, as we come from the left going right, the graph is going down. So that's called a decreasing. And after we get to x equals 2, the graph goes up. And that's called increasing. If you like putting in some arrows here to indicate this kind of motion, all power to you, please do. And let's see. So what we'll say is increasing, the graph is increasing on the interval 2 with a parenthesis, 2 to infinity, and decreasing from negative infinity up to 2. Observe that the point that's at the very bottom here is not included on your intervals of increasing, decreasing. That's always the case. The vertex is not included because at the vertex, the graph is neither increasing nor decreasing. That's basically the reason for that. Okay, so we got that taken care of, and I think there's one more thing, and that is max min values. Okay, so again, parabolas are very stable things. You either have a max value or a min value. And just looking at the graph, I think right off the bat, and this is why I think the graph is also valuable, it looks like a minimum, and it is. It's a valley. It's at the bottom of the valley. So minimum value. Now, here's where we need to say, we have to decide, are we going to talk about a y value or an x value? And the answer is a y value. When I say minimum value of the function, which is what I asked for in this question, the minimum value is going to be a y value. And that minimum value is -3, right there. Y value, not x value. And I think that does it. So that takes care of this problem. And let's see, I think this was problem 10. Please let me know if this was helpful and if any other videos would be helpful too. Thanks.